My name's Ian. Thank you for having me. I'm really excited to be here and to talk to you about the fundamentals of front-end ops. Let me get rid of that cursor so it doesn't annoy everyone. So this is going to be kind of a high-level talk covering quite a lot of the different parts that we talk about and which we sort of relate to with front-end ops. Because it's going to be so high-level, I'm going to pack quite a lot of content in. This is also available on my site, and you can interact with it and get more detail by hitting I at any point. Okay, so Alex Sexton wrote an article in 2013 on Smashing Magazine where he hypothesized on this role of a front-end operations engineer, a role which didn't exist then and which to some extent still doesn't exist now. In it, he said that the metric by which a front-end operations engineer will be judged is speed. And he talked about speed in three different ways. So what we talk about is the speed at which we can get code that we're working on day to day, our features, up to the server. Then we have the speed that we can get that code, that experience, to start happening on the user's browser. And finally, getting metrics and data back from the user, back to the developer, and completing the loop, and allowing us to make better products. There's another part of the talk that I want to make, and that's that the culture of DevOps, which has sort of been established and is establishing over the past few years, is really about stopping throwing code over the wall and blurring the lines between developers and operations, and allowing developers to really sort of take responsibility for the code that they're running on the servers. And this has definitely worked to some extent. The lines have been blurred, and the results of this process have been really good. But I still feel as if front-end is the last one to fall, and there is still this wall between front-end and between the DevOps environment. And I think it's time that we knocked down that wall and took more responsibility and got involved with things that are outside of our editors. So I'm not going to be talking about our editor. I'm not going to be talking about CSS, controversially, but I'm sure there'll be plenty of that today and tomorrow. What I want to talk about is everything outside of the editor. I want to talk about speed and safety of pushing code up to the server, getting that user experience to the user as quickly as possible, and then finally, completing that feedback loop and getting it back to us as developers. Okay, so the fastest way for us to deliver code directly to the server is to change the code directly on the server. And I'm sure you've all been in situations where this has happened before. Ideally, this no longer happens. Whilst it is the fastest way to change the code directly on the server, it's of course not safe. It's an incredibly risky thing to do. And what we want to do to protect the production environment is to create a certain amount of gates that code has to pass through, a certain amount of tests, so that we can ensure that when it gets to the server, it's in the best possible shape. And we also need to de-risk development. And what I mean by that is that if a bug occurs on the live site, or if the site goes down, or anything like that, that it's not the fault of a developer. It's the fault of the system that we created to get that code up to the server. So at no point should there be any blame pointing at a particular person. Our first opportunity to create a gate to look after our code is directly as the user's writing it. And when I say the user, in this case, it's the developer. As we save, as we're actually typing and writing code, we can be using editor plugins to lint our code, to use CSS lint or JS hint or ES lint, and using tools like editor config to make sure that we all have the same kind of setup in our editors. With style guide compliance, I personally don't believe it matters what particular style we write our code in, as long as we all buy into the same philosophy and the same code. What we want to avoid is arguments about semicolons and brackets. These are things which should be just handled up front. And we can use pre-commit hooks. Git and other version control systems allow you to use hooks, pre-commit, post-commit, pre-push, post-push. And we can use pre-commit hooks to remove any accidental code that we know for sure isn't going to be needed in a production environment. Things like console.logs, debuggers, merge conflicts. We need to remove these. And this stage, this first gate, has to be fast, because this is a synchronous part of our development pipeline. Developers are inherently lazy, and this is something that we should encourage and be proud of. We want to ship code, we want to do it as fast as we can. And anything that you put that blocks a developer in this particular situation, they'll find a way around. And yeah, it'll just be pointless. So keep it quick. After we've pushed, after we feel like our feature is ready, we can run some more tests. And this is our first asynchronous part of the development pipeline. This gives us an opportunity to run longer tests, to maybe run the entire suite. This could be done on branch builds, on GitHub, or locally in some other system. But yeah, it's an opportunity for us to run the full test, to run some code size analysis, some quality complexity analysis. And because the user, which is the developer, isn't having to interact with the code at this point, we can take more time over it. The third and very important part of the pipeline is code review. This is a huge topic and probably could be a talk in itself, but I think it's an incredibly important part of the pipeline. Code review, in my opinion, should start before any code is written whatsoever. So if you're attacking a feature, you're coming up with a solution, you should be picking the person who's going to finally review your code and discussing the solution with him. There's no point you spending 2 days working on a particular problem, only for him to have known a better way or her to have known a better way in the first place, and then for it to be a massive surprise. A code review should really be a once-over of the code, and a +1, or perhaps suggestions about different parts of it. And ultimately, it's an opportunity to share knowledge, and something that should be really, really encouraged and never be a personal critique. I mean, GitHub issues are littered with attacks on people's code styles, and that doesn't foster a culture that we want to be a part of, that will provide us with the best products we can make. Code review should be a safety blanket and an opportunity for us to learn from each other. Hopefully, most of you are familiar with continuous integration. But for those who aren't, it's very, very simple. It's simply a centralized near-production environment where we can run a suite of tests and based on a hook of some sort or a pull. So as soon as the developer has given a +1 and merged this pull request into master, we can kick off a build in CI. This can be a real bottleneck in organizations. This is something that causes many problems at Lonely Planet, because we were committing so many times a day and you have so many different developers pushing code into repositories that CI continually builds up. So it takes a huge amount of diligence and work to ensure that this part stays really clean and really quick. But it's a super important part of the pipeline. And finally, once you've passed that gate, that final gate of CI, we need to think about deployment. So at this point, we're pretty happy. We've got a good feature that we think is ready for production. So we need to deploy it. And deployment can be as simple or as complicated as you need it to be. But ultimately, it has to be predictable, consistent, and automated. FTP can be a deployment strategy, as long as it in no way requires a human to move it from one part to the other or to hit and drag files. You might also need to do some things like preparing assets for production, things like uglifying and concatenating files, adding cache-busting shards to the end of files to ensure that we can quickly move forward if we indeed do push something that's broken. And it's worth mentioning the different types of different methodologies that are continuous deployment and continuous delivery. So continuous deployment means that after CI passes, we're taking this artifact of code and we're deploying it somewhere. But it doesn't have to be production. It could be test, or it could be a staging environment where we run some QA. Continuous delivery is where we're pushing code directly into the production environment. So there are lots of arguments against and for continuous delivery, but it's something that we've seen great success with. Some of the benefits being that we push out very small incremental changes, which could be just a couple of commits, so that if we have problems in that code, we immediately know which parts of it are broken. With continuous deployment, where perhaps you run QA for 2 weeks, then you release a package, there's going to be a lot of commits, and we're not really sure which things are going to break in that part. So there's also an argument that not having that QA scenario and using your real users to test things for you can provide you much better feedback than a tester. But if you've done all these things, finally, you'll hopefully have got some really good code up to the server, and it should be safe and secure and not going to break you. The next thing we need to think about is how to get that code to the user as fast as possible. These are things that front-end operations engineers need to be on top of, but which all of us should be thinking about at the same time. So we need to enable a fast user experience. The most important part of this fast user experience is protecting the application. The slowest experience is a broken experience. If the site's down, there's no way we can have the critical path doesn't matter if we don't have a site. So we need to offload as much as possible and protect the application. We also need to know what to prioritize and kind of understand an overview of the entire stack of the code getting to the users, so we can work out where it's worthwhile putting our time, investing our time. For example, optimizing a not very hot function isn't really going to give you as much benefit as perhaps looking at different caching strategies. And you need to understand the critical path, which you all do, and they're experts because you just saw a talk by Scott. So at the application level, this is kind of the domain which I guess people will be mostly unfamiliar with, because this is kind of more typically a back-end job to work on the application. But it's still very relevant for you as front-enders to be able to inform and help back-end developers to work out which are the most important parts of the application. And we talk about something called protection via prioritization. And what we mean by this is that when we request something from the server, let's say it's an article, we need to ensure that the most important content can't be broken by something insignificant or complementary. So if it's an article, we want to ensure that something that breaks in the comment service or the footer service can't break the actual content of the article, which is the most important part for the user. This is something which the Guardian have called swim laning, and which they use to really great effect on their site. And another thing to think about is, where's your origin server? As we know, latency is a huge killer and something which we can't do anything about. Lonely Planet operated their origin out of Melbourne for many years, but a lot of our users were in the US and Europe. So it's something to just think about, rather than just automatically putting your server in US East, as lots of people do. Go where your users are. Okay, the network. We need to understand it. We need to understand the protocols. This is, again, a talk in itself, and something that Scott covered really, really well. As an operations engineer, front-end operations engineer, we need to kind of understand the full gamut of the network, but not necessarily have to go too deep on each part of it. I find that it's very hard to keep up with all the latest and greatest performance hacks and techniques that we come up with. I mean, there are books about it constantly. There's a conference about it. It's really difficult, but if you understand the protocols and you understand why these hacks come about, it makes things a little bit simpler. So for example, if you know why it's expensive to open up a new TCP connection, then it makes sense why you'd want to concatenate files and keep reusing those connections. But ultimately, plan for failure. The network is going to fail you at times, without a doubt. And if you have a site that can be resilient to that, then you're in a much better position than lots of other companies. Finally, get secure. There's been, for a while, there's a site called Is TLS Fast Yet? There's been lots of debate about whether TLS is something that is quick. It's not as quick as running a non-secure site, but it can be tuned to be as quick, or very close to be as quick. And ultimately, as we saw in the last talk, HTTP2 is coming out, and right now, the main browsers are only going to support it over TLS. So in that case, security is by far faster than an unsecure content because you're suddenly allowed to use these new features. Okay, so the CDN. Again, I assume most of you know what a CDN is, but for those who don't, a content distribution network essentially is someone else's hardware scattered around the world which can store your static files. It allows you to cut latency by quite a bit and put your content as close to them as possible. So you want to be caching as much as you can. You want to be offloading everything from your server and putting it as close to them as you can do. This might include static files, language files, DNS lookups, anything you can think of. It could be the entire page. If you're serving HTML, which is static, which doesn't change, you can cache that entirety right at the edge and puts you in a great position. Unfortunately, that can also bring its own problems. I'm sure we've all been in a situation where you've made a change and refreshing the page and nothing's changing, nothing's updating because there's some cache in some place which hasn't been exposed. So once you start caching things, expose that to the team. Make sure everyone knows the different layers of caching that you have and how we can bust each part of them to ensure that we can keep working. Also understand that as soon as you do cache the full page on the edge, you suddenly can't take advantage of things like cookies and headers on the server. So you need to have robust solutions for handling things like personalization, localization. Make sure that that doesn't get in the way of development and make the development process slower, but still use these tools. Finally, when you've gone all the way along there, you finally get your work to the browser, and we can start executing it. There's a whole host of optimizations we can make at this stage. The critical path, as we just saw, can be hugely beneficial by tweaking that and pushing as much stuff into the head. But we can also do other things like tuning our cache hit rate. What I mean by this is if users are hitting the home page and often going to page B and page C, then we should be sharing the cache across those three files, optimizing them in that way. If users go to those pages but don't often go to page D, and page D happens to have a very heavy weight on it, make sure these things are separate concerns and that we don't have any overlap between them. Leverage new file formats. WAF2 over WAF ultimately offers a very similar, if not the same experience at a lower cost. WebP and JPEG XR are new formats for images which can offer like really big benefits, particularly for big landscape images where you can have huge savings. And favor things like SVG when you can, because they have great compression. And keep an eye on your frame rate. This, again, a talk in itself. But there are things we can evangelize and work on to help with keeping things silky smooth. Things like turning off hover effects as we scroll, which can be done site-wide and just allows the developers to not have to focus particularly on those single solutions at any time. All right. If you've done all that, we should hopefully have a really great product at this stage. But hopefully it's not going to be good enough. We need to know for sure that what we think is happening on the user is actually happening. And we need to make sure we get this feedback loop coming back so that we can make better decisions on what we develop. So we need to set up monitoring. There's a lot of things we can be monitoring. JavaScript errors are a huge thing. If you're not monitoring JavaScript errors, you could be missing some huge problems on your site. It's not hard to do. There are services like Track.js and GetSentry which can do this for you, or which can help you. And particularly in the evolving role of client-side applications now, we should be treating these errors as importantly as if we were treating a 500 on the server with pingdom alerting us. Like, this is the same thing now. And if we're not on top of that, then we could be missing some huge problems. Start monitoring real user performance. The performance metrics are available in almost all modern browsers. And we have ability to do custom timing metrics as well. So measure what's happening on page load, but also measure when the user's getting your actual content. Look at things like time to first piece of content, and then trend that over time, so that you know that if you release something that causes that to flag up high, that you can roll back or make adjustments. And monitor your asset sizes. This is something, I guess, related to a performance budget, but it's something that I think should be done in a production environment rather than locally or in a sort of CI environment. The reason being that we, at one point at Lonely Planet, we broke gzip by releasing some bad VCL to our Varnish config. And asset sizes, of course, shot up massively, particularly as we were using gzip as a performance hack, really, for some of our things using SVG. And without a doubt, this would have caused the pages to be completely unresponsive for some users over very poor connections. So again, this is a 500. This is the site being down. And if we're not monitoring this kind of thing, we might be missing out on these things. We should be thinking about how we can enable A/B testing. This doesn't have to mean testing a blue button versus a red button. This can mean testing a performance implementation versus a different one. It can be anything. But we need to make sure it's simple to spin up a new test, simple to get the reporting back. And ultimately, this will empower developers to actually run these tests, to experiment on themselves. And having that kind of tight feedback loop can really sort of empower developers to push forward and work on the product to make it the best it can. If you're getting this feedback, expose it. Make it really, really accessible. Get dashboards and screens around your office, evangelize it. As we said, developers will always find the fastest path. If we don't, they've got project managers shouting them to get things done. If we don't make this really accessible, it won't get used. So even if they have to log into something, just make sure they don't. Make sure it's all there. And reduce the signal to noise ratio. If you have 500 graphs, this is obviously something that can't be kept on top of. Work out which are the most important graphs and get those in front of the developers. Use smoothing algorithms to get rid of variance in graphs and just to show which parts are actually spiking up and down. And set up alerting so that when we do have these things, we can alert users, developers straight away. And refine and evolve this process, because what might be the best graph today, which measures part of your application, might not be tomorrow. So we need to consistently be checking and changing this process. And use the feedback. So expose it, but use it. Decide what's the best feature to be working on next based on the feedback. Decide which bugs are the most important ones that you need to fix immediately. And remove hippos from the equation. Hippos stands for highest paid person's opinion, and they have no business whatsoever being anywhere near our budget, what we work on. It doesn't matter what they think, it matters what our users think. It doesn't matter what they want, it matters what our users want. And that's ultimately going to help us make better products. So it's all about speed in these different parts, but it's also about just looking after this whole process. The front-end ops engineer really has to be on top of these different parts and to be working them. And these three parts all have to be in sync for us to make great products. We can't create a fast user experience without the fast feedback back. And we need to have safe delivery, or the site can go down and then we have no user experience. So that's the full cycle. I guess the question really is should front-end ops be a role? There's enough work working on all this stuff for 10 people on any project, without a doubt. So if you can afford it, I think front-end ops should be a role. I think you do need somebody or a team working on these different parts and tuning them and making them as quick and as fast as possible. Working on the features outside of features so that other developers can work directly on what's most important. But at the same time, one person or two people working in the front-end ops engineers can't change a culture. And we need to be collectively leveling up about working on these types of things and understanding that our websites aren't executing in our editors, and they are executing far away from us in many, many different environments, and we need to be on top of that. And it's good to work on this stuff. It's fun to step out of the CSS JavaScript world and think about how we can work on these things and make them faster. So with that, I will say thank you and implore you to take away some of this if you can. Think about how you can fit it into your cycle and how you can make better products which your users are actually wanting. So thank you very much for listening.